In this video, I will introduce the integral test. The integral test, for us to use it, the function that we have has to be positive, continuous, and decreasing. And if it's positive, continuous, and decreasing, I integrate the function. If I get a value, then it converges. If I do not get a value, then it diverges. Okay, so whatever the integral does is what this series does. So for example, the first one, if we were to integrate this, we're going to integrate. I'm going to take out the n and replace it with x. So we're going to get x over x squared plus 1 dx, and we're going to go from 1 to infinity. So we need to apply improper integrals here. So we're going to say the limit as b goes to infinity, integrate from 1 to b, and then we have x over x squared plus 1 dx. We can do this as a u sub. If u is equal to x squared plus 1, du is 2x dx, du over 2x is dx. So we've got the limit as b goes to infinity. The x stays, this becomes my u, and then dx is du over 2x. These cancel, I can take out the 1/2. When we integrate, we get ln. So I've got the limit as b goes to infinity, 1/2. So it's ln of u, which is x squared plus 1. So I'm going to say ln of x squared plus 1, and we're going to go from 1 to b. Plug in my bounds, you get the limit as b goes to infinity, 1 over 2. So it's ln of b squared plus 1 minus 1/2 ln of 2. Because if I plug in the 1, we get 1 plus 1, which is 2. Now I drop in my infinity. So we plug this in here. Remember, ln of infinity is infinite. So this diverges. Again, infinity. So we'd say that this diverges. So to answer the question, we would say that this diverges by the integral test. All right, for number 2, looks like we have arctan. So I'm going to rewrite this as, so from 1 to infinity, 1 over x squared plus 1 dx. I've got the limit as b goes to infinity. So it's going from 1 to b, and then 1 over x squared plus 1 dx. So when we integrate, we get arctan. So limit as b goes to infinity. So we get arctan of x. And we go from 1 to b. I drop in my bounds. So we get arctan of b minus arctan of 1. Arctan of b, we have to plug in infinity. Remember, arctan of infinity is pi over 2. Arctan of 1 is pi over 4. So we get pi over 4. So it converges. For number 3, I'm going to let u be equal to ln of x. du is 1 over x dx. Then x du equals dx. So I set up my integral. So we're going to go from 2 to infinity, 1 over x ln of x dx. So we're going to do it as a u sub. So I've got the limit as b goes to infinity, 2 to b. So we have the x stays, u becomes, well, u is your ln of x, so this becomes u. And then for dx, it's x du. So cancel, cancel. So we integrate, we get ln of u, but ln of u is ln of ln of x. So we've got the limit as b goes to infinity. My bounds are from 2 to b. If I plug in my bounds here, we're going to get, so ln of b minus ln of 2. This is going to diverge. Remember ln graph? Let me just draw it real quick. As you must know the ln graph. So it looks like that. So as I go to infinity, so does my graph. So this goes to infinity, so this diverges. For this one, now, in the next video, we're going to do something called p-series. So you would really not do the integral test for this, but we did this when I first introduced improper integrals. So what we did was we integrated from 1 to infinity 1 over x squared dx, and we said that that converged. But let's just do it. So we've got the limit as b goes to infinity. We're going to integrate from 1 to b, and then it's x to the negative 2 dx. We raise it up by 1. So I've got the limit as b goes to infinity. So we get x to the minus 1 divided by negative 1, which is negative 1 over x. Plug in my bounds from 1 to b. I've got the limit as b goes to infinity. So plug in your top bound minus your bottom bound. I plug in that, goes to 0. I get 1, so it converges. For number 5, we're going to integrate from 1 to infinity. It's 3 over 2x minus 1 dx. It's an ln. At this point, you should be feeling more comfortable that you can do this without a u sub at this point in the course. But if we let u be 2x minus 1, du is 2 dx, du over 2 is dx. You have to remember to divide out the derivative of this. So it's ln, but we have to ln of 2x minus 1, but we need to make sure we divide by the 2. So I'm going to do that all together. So we're going to do the limit as b goes to infinity. So it ends up with 3 halves. I have this 3 I'm taking out. This 2 I'm dividing. And then it's ln of u, but ln is 2x minus 1. And we're going to go from 1 to b. So we've got the limit as b goes to infinity, 3 halves. So it's ln of, so 2b minus 1 minus ln of 1, which goes to 0. But this part here, when I plug in, so I have to plug in this. For that, again, I have ln of infinity, which diverges. So the whole thing diverges. For number 6, I'm going to rewrite this. We get ln of x over x from 3 to infinity. I'm going to do it as a u sub, so u is ln of x. Du is 1 over x dx, then x du equals dx. So we've got the limit as b goes to infinity. U over x, this is dx up here. So for dx, I'm going to plug in x du. Those cancel. So now we can integrate. We're going to get u squared over 2, but u is ln of x. So I've got the limit as b goes to infinity. So it's u squared over 2. I'm just going to do it as ln of x squared over 2, and then plug in my bounds. So 3 to b. And again, you start to see a theme here. A lot of times, most of the time, when we have ln of x on the top, and we're talking about infinity, it's probably going to diverge. but you should probably do it. So we're going to get L limit as b goes to infinity. So plug in. So we get ln of b squared over 2 minus ln of 3 squared over 2. When I drop this in here, this diverges.